If you find this video useful, like and subscribe to this channel for additional content. Alright, so in this lesson, we shall apply more of the product rule to various questions, okay? So let's start with this first question. Find the gradient of the curve y is equal to x squared root x plus 2 at the point this. So what are you to find? Gradient, okay? But our interest is on this curve, all right? This curve is a bit different. Why? Because it's not a simple curve to differentiate. It is the product of two functions, okay? So we shall use the product rule to solve it. We have y is equal to x squared root of x plus 2, all right? So let u be equal to the first function, which is x squared, and then v be equal to root of 2, okay? Root x plus 2, that's the second function. But this can be cleaned up a little bit, so you have x plus 2 all raised to the power half. So let's take the differential. Du dx gives you 2x, okay? Then dv dx. Now, this is chain rule. So what do? Differentiate the outer function, which is half x plus 2. So minus 1 gives you negative half, okay? Times the differential of the inner bracket, and that gives you 1. So the product rule says dy dx should be equal to u dv dx plus v du dx, okay? So what is your u? X squared. So you have x squared times dv dx. This is dv dx. 1 times half is still half, so I'll just keep the half. X plus 2 raised to the power negative half, okay? So, all right, okay. Plus v. What is v? This is v, okay? So that is x plus 2 raised to the power half times du dx, which is 2x. So let's clean it up a little bit. So we have this times that will give you x squared, okay, over 2, then times 1 over x plus 2 all raised to the power half, okay? Then plus you have 2x, x plus 2 raised to the power half. Then x squared over 2 square root of x plus 2, okay? Plus 2x, and then x plus 2 all raised to the power half, but you could just take the square root of it. That's also fine. Okay, but the question said we should find a gradient at this point, okay? So dy dx at x equals 2 will be equal to, just put 2 at the various points you see x, okay? So we have 2 squared over 2 into 2 plus 2 plus 2 into 2 square root of 2 plus 2, okay? All right, so this will give us 4. So dy dx at x equals 2. This will give us 4. Then we have 2 root what? 4 plus 4 into root 4, okay? So 4, root 4 is 2 times 2, which is 4. Then 4 into 2, okay? So we have 1 plus 8 giving us 9, all right? So the gradient of this curve at the point s equals 2 is 9. Let's take the second example. find the x coordinate of the points on the curve y equals 2x minus 3 all raised to the power 3, x plus 2 all raised to the power 4, where the gradient is equal to 0. So we know gradient is equal to 0, okay? Now, we are also told to find the x coordinates, okay? So we are looking, coordinate is x and y, all right? But this question wants us to find only the x of the points. So we will find more than one x value. Put that one in mind, okay? So let's start. We have two functions multiplying themselves, okay? So we have 2x minus 3 raised to the power 3, then x plus 2 raised to the power 4, okay? So let u be equal to the first function. So we have u is equal to 2x minus 3 all raised to the power 3, okay? And then v is equal to x plus 2 all raised to the power 4. Chain rule says we should differentiate both, okay? So we have du dx. Remember that this is a chain rule, okay? So this is what we are going to do. We will differentiate the outer, then we differentiate the inner, okay? So we have the outer 3 comes here, then we have 2x minus 3. You subtract 1 from here, which is 2, all right? Times, then go inside the bracket and differentiate. You get 2. So you clean it up and you have 6 into 2x minus 3 raised to the power 2, all right? So let's deal with the v. dv dx is also chain rule, so the 4 comes down, okay? Then you subtract 1 from it, so you have 3. Then you go inside the bracket and you differentiate, you have 1. So your final answer is 4x plus 2 raised to the power 3, all right? Now, the product rule formula is dy dx is equal to u dv dx plus v du dx. And the reason why we are using the product rule is because two functions are multiplying. So we use the product rule. Now, we have found dv dx already, which is this, and we have found du dx, which is this one. And we have our u and v, okay? So we are good to go. U, so which is 2x minus 3 raised to the power 3 times dv dx, and this is what we got, 4 into brackets x plus 2 raised to the power 3. Then plus, what do we have? V, right? So this is v. X plus 2 raised to the power 4. What else? Times du dx. What is du dx? 6 into 2x minus 3 all raised to the power 2. So 6, 2x minus 3 raised to the power 2. All right? So we can clean up a little bit. Okay? Right? Let's see if everything is in order. This is u, and then we got this from there. Okay, we are good to go. So let's factor a few things out. This is what is here, and this is also there. So it means they are common factors. We can factor them out. We have 2x minus 3 raised to the power 3, but we have 2x minus 3 raised to the power 2. So we can factor this out. So we have 2x minus 3 raised to the power 2, okay? Then we have x plus 2, okay? X plus 2 is also here, but this is raised to the power 3, this is raised to the power 4, which means we can factor out x plus 2 raised to the power 3. Now, when we do that, what do we have? We have x plus 2 raised to the power 3, okay? We can also factor out 2 when it comes to the 4 and the 6, okay? So when we factor out 2, what are we left? This is here, this whole thing is here, power 2, which means it's left with 1. So we have 2x minus 3, okay? Then 4, we have factored 2, which means it's left with 2, okay? Then this, okay, is raised to the power 3, and this is what we have. So we factored it out. Now let's come to the second term. We have 2x x plus 2 raised to the power 4. We have x plus 2 raised to the power 3, which means we are left with 1 of the x plus 2. All right, this is 6, and we factored out 2, so we are left with 3 here. Then this is 2x minus 3 raised to the power 2, and we have 2x minus 3 raised to the power 2, so we are done with it. Okay? All right, so this is dy dx, this is dy dx. Okay, so we have 2 into 2x minus 3 raised to the power 2, x plus 2 raised to the power 3, all right? Then let's clean up the inner bracket. So this will be 6, this will be 4x minus 6, and then we have 3x plus 6, okay? All right, then we finally clean up. So we have 2, this, okay, x plus 2 raised to the power 3, all right? Now this is negative 6, positive 6, so they cancel out. So this plus that will give it us 7x, okay, or equals 0. Why is it equal to 0? Because they said the gradient is 0. Of course, you could have equated it to 0 from the beginning, all right? It wouldn't change anything. Okay, so this is what it means. All these are equal to 0, okay? Now, this is a constant, so you can divide through by 2, all right? So it means you are left with this squared, this plus this cube, and then 7x equals 0, all right? So 2x minus 3 all raised to the power squared is equal to 0, or x plus 2 raised to the power 3 is equal to 0, or 7x is equal to 0. So this will give us, you take the square root of 0, which is 0. So you have 2x minus 3 equals 0, all right? So x will be equal to 3 on 2, all right? Let's deal with this one. This is, you take the cubic root of 0, which is still 0. So x is equal to negative 2. Then x is equal to 7. That is when you divide through by 7. So the question said, find the x coordinates, all right? So let's conclude. Therefore, the x coordinates are, we have negative 2, 0, 3 on 2. So keep in mind, we were looking for x coordinates of the points. So you are looking for more than one point. That is why we have 1, 2, 3, okay?